Science and Technology Class 03. Satellite Navigation. These satellites allow a small electronic receiver to know its precise location, i.e. latitude, longitude, and altitude, with high accuracy. The point needs to be in the line of sight of at least 4 satellites to know its precise locations. GPS, USA. GLONASS, Russia. Galileo, Europe. Beidou, China. NAVIC, India. NAVIC. It stands for Navigation of Indian Constellation. It is a navigational satellite system developed by ISRO. It comprises 7 IRNSS, Indian Regional Navigational Satellite System, satellites. 3 satellites in geostationary and 4 in geosynchronous. Similar to other navigational satellite systems, it provides 2 types of services: standard services for civilian use and restricted services for military use. NAVIC. GPS. It is regional. NAVIC services are available in India and 1,500 kilometers beyond India's border. It is a global satellite system. There are 7 satellites. There are 32 to 33 satellites. Satellites are placed in geostationary and geosynchronous orbits. Satellites are placed in medium Earth orbit. Very low cost compared to GPS. Higher cost. These satellites have applications in many areas, such as A. Aerial, terrestrial and marine navigation. B. Vehicle tracking. C. Integration with mobile phones. D. Precise timing. E. Disaster management. GOGAN. It stands for GPS-aided Geo-Augmented Navigation. It is used for civilian aeroplanes, mainly. This was developed by the Airport Authority of India and ISRO, jointly. It can be used to tell the precise location of aeroplanes at any time. Launch vehicles of ISRO. The purpose of the launch vehicle is to send a manned-unmanned mission to space. It can have the following major components. A. Payload box. B. Engine. There can be 2 types, air-breathing and non-air breathing. Non-air breathing engines carry fuel and oxygen together, for example, PSLV, GSLV, etc. Air-breathing engines fulfill their oxygen requirement from the atmosphere. For example, jet, ramjet, and scramjet. ISRO has developed the VCAS engine, which operates using liquid fuel. Rocket fuel, propellant. It can be of 2 types, solid fuel and liquid fuels. Solid fuels. Solid fuels are simpler, safer, and cheaper. However, once they start burning, the resulting thrust cannot be controlled. For example, HTPB, hydroxy-terminated polybutadiene. Liquid fuels. The flow of liquid fuel to the engine can be regulated. Hence, the resulting thrust can also be regulated. However, liquid fuels require special transportation and storage infrastructure because of safety issues. It makes them expensive. For example, UDMH, unsymmetrical dimethylhydrazine, plus N2O4, MMH, monomethylhydrazine, plus MON, mix of nitrogen oxides. Launch vehicles of ISRO. A. Past. A. Satellite launch vehicle. 2. Augmented satellite launch vehicle. B. Present. A. Polar satellite launch vehicle. 2. Geosynchronous satellite launch vehicle Mk3. 3. Launch vehicle Mark III. 4. Small satellite launch vehicle. C. Future. Next generation launch vehicle. 2. Scramjet. PSLV. It is one of the world's oldest and most reliable launch vehicles. It has 4 stages, which operate between solid and liquid fuels: solid, liquid, solid, liquid. Capacity is about 715 kilograms in 600 kilometers polar orbit and 1,425 kilograms in geosynchronous transfer orbit. It is capable of placing multiple satellites into different orbits. Some of the key launches such as IRNSS, Chandrayaan-1, etc. took place with the help of PSLV. GSLV Mk2. It was designed to launch the communication satellite in geosynchronous transfer orbits. It has 3 stages: solid, liquid, and cryogenic. The capacity is 2,500 kilograms in GTO and 5,000 kilograms in the LEO. LVM-3, GSLV Mk3. As of now, it is the most powerful rocket of ISRO, with a capacity of 8,000 kilograms in the LEO and 4,000 kilograms in GTO. It has 3 stages: solid, liquid, cryogenic. Recently, it made the record of launching 36 satellites of about 6,000 kilograms in LEO. These satellites belonged to OneWeb. In the past, it has also been launched for the Chandrayaan-2. Cryogenic stage. Cryo signifies very low temperatures. In the cryogenic stage, fuel or oxidizer or both can be stored at very low temperatures in the liquid stage. For example, liquid hydrogen and liquid oxygen. Such engines pose engineering challenges because of associated thermal and structural problems. However, they provide more thrust than typical solid or liquid fuel. Small satellite launch vehicle. It is a small rocket with less capacity, 500 kilograms in LEO, and it can be deployed in less time and cost less. It has 3 stages. All the stages use solid fuel. The first SSLV launch failed. It was not able to achieve the desired orbit. Recently, the second launch occurred, which was successful. Next generation launch vehicle. ISRO is planning to design a rocket to launch a payload of 10,000 kilograms in a geosynchronous transfer orbit and 20,000 kilograms in LEO. This rocket will have a variant that will be reusable. Reusable rockets reduce the overall cost, as many components of the rocket are made of rare components which are in limited supply. The reusable variant will have less capacity compared to the variant which can be used only once. The topic for the next class: Achievements of the ISRO, Future Missions of ISRO.